Hello, welcome back to the video series dedicated to the textbook overview, blueprint reading, construction drawing for the building trades. This video reviews chapter 4, Understanding Dimensions. So what is a dimension? It's a numerical value expressed in an appropriate unit of measure. It is indicated on drawings along with lines, arrows, symbols, and notes to define the size and specification of an object. And it's really critically important to understand the dimensions that are used on the drawings. So, and again, that can be in the imperial system and the metric system. So let's take a look at a few different types of dimensions. So they can be linear, they can be ordinate, they can be angular, radial, diametric, and aligned. And again, please go back to the textbook, check all the diagrams and all the images that are there. So dimension lines are generally continuous with the number being centered and slightly above the line. Or the dimension line is broken, typically that's on the engineering drawings, and the numerical dimensions is positioned in the break. Both feet and inches need to be shown. Even if the dimension has no inches, the zero remains as part of the designation. When dimensions are small, that are less than 1 foot, only inches are used. Overall or chain dimensions are placed outside the smaller dimensions. Arrowheads, dots, or slashes are placed at the extremities of dimension lines to indicate the limits of the dimension. Dimensions reflect actual building sizes, irrespective of the scale used. Where grid lines are used on the drawing, such as on the modular drawing, it's not necessary to dimension all the grids. Only one grid is normally dimensioned. Similar dimensions need not be duplicated on the various views. Door dimensions may be indicated in the floor plan symbols or given in the door schedule. Curved or angular leaders are often used to eliminate confusion with other dimension lines. Dimensions showing location are given to center lines of doors and windows on plan views. To avoid costly mistakes, it's strongly advised to study all the information available before making a determination regarding the dimension in question. Check that there is no conflict or discrepancy with the information shown in other views. And also, you need to cross-reference the specifications to understand if everything is indicated correctly. So, using scales. Just because building projects are too large to be drawn to actual size on a sheet of paper, everything needs to be drawn proportionally, smaller to fit. And there are a few different scales. So the scale used on construction drawings depend on the actual size of the building or object, the amount of detail required to be shown, the size of sheet selected for the drawing, the amount of dimension and notation needed, and common practices that regulate certain scales. For example, normal residential structures are generally drawn at 1/4 inch, that is equal to 1 foot. Architect scales, that is, and I have it here, actually, I can show it to you. So this is the typical architect scale, and you can see that there are different dimensions here. So it can be 3/16, and then you flip it as a 1/4, and then it's like 3/8. So that is used to understand actually the scale of a drawing. There are cuter versions like this one. So this is like a smaller one, but actually it's the same thing. It's basically just showing the scale that can be used, so you can easily interpret that. Please do not mix the architect scale with the engineering one, because they use a different one, and that is actually slightly showing slightly different dimensions and the scale. So, like I mentioned, the scales are designed to measure feet, inches, and fractions of an inch. So, for example, 1/32 of an inch equals to 1 foot, or 1/16, or 1/8, or 1/4. And in metric equivalent, it's 1/50, or 1/100, or 1/200, or 400. So please get familiar with that. Learn how to use that. If you're really interested, there are tons of educational videos on YouTube. You can definitely check them out, because this is really interesting to know how to use them when you have a hard copy of the drawing and you use this scale. So yes, the civil engineer scale is different. So they are similar, but based on really different scales. And the engineer scale has 6 scales: 10, 20, 30, 40, 50, and 60. And other specialty scales are divided into even small increments, such as 100. So again, there are tons of beautiful drawings in the chapter. So please get back to the chapter, check them all out. They're really clear and really nice, and that will help you navigate the drawings. The next one is linear dimensions. So linear dimensions are 2D dimensions, that is actually the distance between 2 points. So since 2 points define a line, the unit of distance is sometimes called linear units or dimensions. In the metric system, linear dimensions are generally in millimeters. To avoid having to specify mm after every dimension, a label such as all dimensions are in millimeters, or unless otherwise stated, all dimensions are in millimeters, is usually contained in the title block. Then in the architectural engineering drawings, the most important dimensions determine subsequent dimensions, providing a dimension standard. So if a wall is dimensioned to its center first, all following dimensions using this wall as a reference point should be dimensioned at the center. So also area dimensions are two-dimensional, and they measure area. They're often but not always expressed as squares of linear dimensions, such as square inches, or square feet, or square meters, or square millimeters. Then volume dimensions are three-dimensional, and that they are expressed as the cube of linear units. So two methods of dimension are in common use. Unidirectional, those are the dimensions are written horizontally, and aligned, and those are the dimensions that are written parallel to their dimension lines. A line dimension should always be readable from the bottom of or the right of the drawing. And again, that is just because back in the day, the sheets were flipped in the field, and that needed to be actually in the bottom right corner, so it will be easier to see that. Again, please check all the different drawings here and graphical representation. Angular dimensions are used for measuring and displaying inside and outside angles. Where greater accuracy is required, the degree is divided into 60 minutes and the minute into 60 seconds. For reference, the circle is 360 degrees. Then reference dimensions. The reference dimension is used only for informative purposes. The indication REF or ref should be noted immediately under or beside the dimension. Normally, it's either duplication of a dimension or the accumulated value of other dimensions. Nominal size and actual size. In architectural, nominal size refers to the dimensions of sawn lumber before it's dried or surfaced. And there is a chart where you can actually see the examples of nominal and actual sizes for framing lumber and boards. And if it's like a 2x4, the actual size is 1.5 by 3.5. So please just make sure that you are familiar with that, and just when you hear the reference, you will already know what actually people talk about. Also, tolerances. The phrase geometric dimension and tolerancing, or GDT, refers to the allowable variation of a dimension. It represents the difference between the maximum and minimum acceptable limits. All dimensions except basic, reference, nominal, maximum, or minimum dimensions must have a tolerance. GDT is a method of specifying the functional geometry of an object. And also, it's important to know that sometimes drawings are not to scaled, and that will be referenced there as well. And you will see NTS as that stands for not to scale, and that means that not all the dimensions are shown there. So, and that covers our chapter 4. I will see you in chapter 5. Thank you.